Hello everyone, Chip Plus from LCI Corporation. Today we're going to continue our discussion on the thin film dryers, focusing today on heat recovery from the drying process. So with that, let's get started. So why would we consider heat recovery? Well, dryers are energy consumers requiring heat for the drying process. Due to climate change, it is important as ever that we consider energy reduction in net zero processes. Additionally, heat recovery can reduce the volume of condenser water required and reduce the amount of condensate sent back to the plant for treatment. These can also reduce the energy consumption of a wastewater plant. Finally, it's a simple addition. It's easy to add on to the drying process. But today we're going to focus on the energy reduction side of heat recovery. So to understand where we can recover heat, we first have to know where the heat is. On the left is a diagram of a thin film drying system. What you notice is there are two streams coming in. There's the heating medium coming in and the sewage sludge coming in. The heating medium is going to transfer its heat into the sewage sludge. This is seen in the streams which are exiting. You have the heating medium going out with a lower heat content, the dried sludge going out, and the vapor going out at a higher heat. The pie diagram on the right shows you where the heat is transferred. And if you notice, 98% of the heat is transferred into the vapor. Therefore, we're going to concentrate on recovering the heat through the condensation system. So let's talk a little bit about the heat cycle as it relates to changing water into vapor and vapor back into water. First of all, we apply heat into the dryer. This is a thermal fluid at about 400 degrees Fahrenheit. This adds sensible heat to the water coming into the dryer and then also latent heat to turn that water into vapor. That vapor is going to exit the dryer at about 212 degrees Fahrenheit. The vapor then heads to the condenser, where it is turned back into water by removing latent heat and is also cooled by removing some sensible heat. In this case, we can get hot water out at about 185 degrees Fahrenheit to use for other processes. As always, heat is going to flow from high temperature to low temperature, and that is what we are showing in this diagram. Now that we've talked about where we can recover heat, let's go through a theoretical heat recovery example. In this example, I have simplified the calculations and rounded some numbers, and for a detailed calculation, we have to use project-specific parameters. In this example, we're going to feed to the dryer 2,200 wet pounds an hour at 20% dry solids, and we're going to dry that to 90% dry solids. That works out to around 1,700 pounds an hour of water evaporation and will require about 2 million BTUs per hour. This equates to an energy usage of around 1,180 BTUs per pound of water evaporated. And in this example, we're going to recover heat in the form of hot water at around 185 degrees Fahrenheit. So knowing we need to transfer about 2 million BTUs per hour of heat into the sludge via the dryer, where does all that heat go? We already discussed that the heat leaves via the vapor stream and the solid stream. The pie chart on your screen shows a further breakdown of where that heat can go and shows that we can recover about 78% of that heat out of the vapor stream in our heat recovery process. That heat can be used for other processes inside the plant. So when you look at the final numbers of putting 2 million BTUs per hour into the dryer, being able to recover about 78% of that heat, we can get about 1.6 million BTUs per hour of hot water at 185 degrees Fahrenheit. This means we only lose about 22% of that heat through the process, or somewhere around 0.4 million BTUs per hour. If you do the math, this equates to somewhere around 260 BTUs per pound of water evaporated used through the dryer outside of the heat recovery process. So now that we have the recovered heat, where can the heat be used? It can be used for things such as digester heating or building heat at the wastewater plant. It can be used in industrial processes where a lower temperature heat is needed. It can be used for district hot water systems. It can also be used to preheat the sludge before it goes through the process. Thank you for your time listening to our presentation on heat recovery from thin film dryers. If you have any questions, please contact me at the information provided. Also, please like, follow, and subscribe to our social media.